Okay, this lecture goes along with Chapter 4 of your textbook, which is entitled Repetition Structures. So the topics we will be covering are what is a repetition structure, and then some repetition structures that Python has, which would be the while loop and the for loop. We'll talk about using a loop to calculate running totals. We'll talk about sentinel values. We'll talk about input validation within your Python program. We'll talk about putting repetition structures inside other repetition structures, which they have listed here as nested loops. Related to the loops, we'll talk about break statement, continue statement, and an else clause. And then we will look at turtle graphics a little bit, drawing figures that can be drawn using repetition or loops. So basically, repetition structures are different types of loops. And a loop is something that will execute potentially multiple times to perform the same set of tasks multiple times, possibly on different data. If we didn't use loops, then we would just be copying the code over and over again. Do something for salesperson 1. Now do the exact same thing for salesperson 2. Now do the exact same thing for salesperson 3. So that's very time consuming, makes your program really large, and worse yet, if you find out that you need to change how that processing of employees works. If you have 100 employees, you have to change it 100 different places. Whereas if you're looping 100 times, you would just need to change it within that loop. So basically, that's what a loop is. You should be familiar with loops from 120 or other programming languages. They break these loops down into two types of loops. I'm going to talk first about the second one, the count controlled loop. That's where you're doing something a specific number of times. I mean, you may be doing 0, 1, 2, 3, 4, 5, for example. Or so you would execute that multiple times. So a specific number of times based on an input value or a constant that you code into the program. Now, a condition controlled loop, we have a condition, which we should know from last chapter, will evaluate to true or false. So basically we're saying keep doing this loop while the condition is true. And then presumably at some point in time that condition will become false, and we would terminate the loop at that point. So the condition controlled loop that we're going to talk about is the while loop. So while the condition is true, do something. So when we hit a while loop, the condition is going to be tested. If it is true, then the statements within the loop are evaluated or executed. And then when we hit the bottom of the loop, we go back and check the condition again. So down at the bottom, you'll see it's while condition, group of statements, or block of code. And presumably, something will happen within the code of the while loop that at some point in time will make the condition false, and then the loop would terminate. So here's the logic. I think your book calls this a pre-test loop because we're going to check the condition first. So it's actually possible that if we hit a while loop and evaluate the condition may start off being false, at which point we would just fall out of the while loop and would not execute the block of statements. Like I said, something inside the loop has to change at some point to make the condition false. One execution of that block of code is referred to as an iteration. And the other thing I said is the while loop is known as a pretest loop. That is, we check the condition prior to potentially executing the statements within the while loop. Here is an example where you're using a flag called keep going. So we set it to yes, so that when we check the condition, keep going is going to be yes, that is equal to yes. So then we ask the user to input a value, we perform some calculations, we display the results. And here we're asking the user, do you want to continue? Enter a Y for yes. And if they say yes, it'll go back, and keep going will have been set to yes. So presumably at some point the user, down at that very last input box in the flowchart towards the bottom of the screen, they're going to be prompted, do you want to calculate another commission? And you're going to simply hit return or type no or something like that. And then when it goes back to the decision diamond at the top of the while loop, keep going is not going to be set to Y. So you would fall out of that while loop, and then as indicated, that would be, in this situation, the end of the program. So several times I had said presumably something will change so that you fall out of the loop. If you write a loop in such a way that it never terminates, you have what's called an infinite loop. So what you would have to do, I think we talked about this in chapter 1 when we were maybe talking about idle, is you have to break out. So if you're in idle, there's a menu option that I showed you to break execution or terminate execution of your program. If you're on a Unix machine and running Python from the command line, then the break character is going to be a Control-C. That's the standard Unix break sequence. The classic example, and I may have given this to you before, of an infinite loop can be found on your shampoo bottle, because the shampoo bottle is going to say, get a little shampoo on your hand, shampoo your hair, rinse, and then repeat. So you go back, you do that a second time, and you get some shampoo, you shampoo your hair, you rinse your hair, and then the next instruction is repeat. So they're assuming that basically means to wash your hair twice. But if you were to literally follow those directions, there is no way to stop shampooing your hair. Usually infinite loops are not something you would intentionally code. However, you might make a mistake. One thing I noticed in that flow chart is they asked the user, let me back up here, enter lowercase y for yes, and then, okay, I guess they are checking for lowercase y. But if something happened, for example, you checked keep going for a capital Y, and you told the user to enter a lowercase y, then most likely the user is not going to be able to get out of that loop, because they won't know what they need to enter to get out of that loop. So the while loop, as I mentioned, is a condition-controlled loop. There is some condition that will control whether or not you do another iteration of the loop. You can take a while loop and make it count controlled by making the condition based upon some type of counter variable to count how many times the loop executes. So you can do that if you need. If you do that, there are several parts that you need to do. You have the initialization, which is to set your count variable to some initial value, most likely 0 or 1. Then there will be a comparison within the condition of the while loop to compare that counter to some value. And then at the end of the iteration, you need to make sure you update your counter. Often that's adding 1 to it or incrementing it. And then you go back to the comparison. So you do comparison update, etc. One infinite loop can be created by following this and forgetting to update your loop value, your loop counter. That would cause you to have an infinite loop. So here's an example of using a while loop and making it count controlled. So we set n to 0, say while n is less than 5, do something. And then down at the bottom, we use a shortened version of the increment that we haven't talked about. So since we haven't talked about it yet in the textbook, n plus equal 1 is equivalent to writing n equals n plus 1. So basically, after the equal sign, you would repeat whatever variables on the left-hand side of the statement and then put the operator that precedes the equal sign. So we would do this for n equals 0, we would do it for n equal 1, all the way up to doing it for n equals 4. And then when n gets incremented to 5, 5 is no longer less than 5. So we would fall out of this loop. So this loop would execute 5 times. One thing, and there's debate over if this is a good thing or not, you can have a shortened format of the while statement if you're only executing one line. And that is, you still have your while followed by a condition followed by the colon sign, but instead of having a new line there and then going down and presumably having your block of code, you can put that single statement there. One issue with that is it's real easy to have code that you think is part of your while loop that's not. That's a bigger problem in other languages that are not controlled by white space, that is not controlled by the indentation like Python is. So Python would be more likely to catch that than if, for example, you were in Perl or C++ or Java. The issue is when you go back, if you need to add more statements, like if you take this line of code and say, oh, I really wanted to print n out so that I know it's doing something, or so that I can verify how many times it executes, then you have to put your print statement down there, then you have to move your n plus 1 down and make sure they're indented equally and that type of thing. Another type of loop that's very common in languages is a for loop. That is a count controlled loop, or at least iterates a given number of times. The general format of that is for variable in a list of values, and if you put 5 values there, it will go through and execute that loop 5 times. In this case, the variable that appears after the for keyword is referred to as the target variable, and it's going to point to a new value for each iteration of the loop. So here in figure 4.4 it shows that. So our variable on the first iteration of the loop would have the value or point to the value 1 because that's the first item in the list. On the second iteration, it would point to 2, and then 3, and then 4, and then 5. So that way we can use a variable name to substitute for whatever position we're pointing to in the list. Now, it's real common for this to be a truly based count thing where you're counting with numbers. And there's a function that is real handy for this called range. Now, range does different things depending upon how many arguments you're given. If you only give one argument, that is specifying the highest value in the range. If you give 2 arguments, you're giving a starting and ending value. And if it has 3 arguments, then the first is the start value, the second is the ending limit, like the 2 argument situation, but the third is going to be a step value, or you might refer to it as an increment, how much we're going to increment each time we go through. So here we're going to look at an example where we want to calculate the square root of each number in a range. This will also allude a little bit to things we need to know about for your second programming assignment. Basically what happens is, as a programmer, you may hard code a range in if you actually do know how many times it'll execute. Otherwise, you might ask the user, how many times you want to execute, and then use that value as the upper limit of the range. So most times, the range is in increasing order of magnitude, or not order of magnitude, increase in value, often by 1, but you might count by 2s, you might count by 3s. But you can actually generate a range that is in descending order by giving the larger value first, the starting point. The ending point would be smaller, and then in this case your quote increment would actually be a decrement, because in this case they're showing you that it would be -1. So it would count 10, 9, 8, etc. As far as running totals, this is a really common thing to do. Basically, you have a loop that's going to read a series of numbers, and then you have an accumulator or a running total variable, and then at the end of the loop you have the total, and you will do something with that. So this might be information that's handy in your Programming 3 assignment that will be given to you soon. So for example, I have programs to calculate your grades. So I ask how many grades there are, and then I ask for that many grades, and as I enter the grades, it does a running total, and then it takes that running total and divides it by the number of assignments there were, and then that gives me the student's homework grade. And then I would actually go back and do that for the next student. So we haven't talked about it yet, but there's an example of where I have a loop within a loop. For each student is the outer loop, and then the inner loop is get X number of grades for the student. Calculate the average, and then it would go back to the next student in the list. Here is an example. A lot of times if you're doing a running sum, that's going to start at 0. If you're multiplying things together, your starting value would start at 1. And then if there's another number to read that number and add it to the accumulator variable, and just do that till there's no more values to read. Then when you exit the loop, accumulator is set to your running total. We have a normal assignment, which is the equal sign, which I told you often gets read as gets set to. The thing that we looked at before, the plus equal, is called a shorthand operator. And basically, as you will see here, putting operators before the equal sign will be equivalent to variable equals variable operator, and then the right hand side of the expression. So here's some examples of their shorthand operators. So it's a very common thing to do running totals or accumulators or counters. So they're just trying to make it easier. Now in Perl even shortcuts it or shortens it one additional thing. I don't want to confuse you, but for example, you can say variable plus plus, and that is equivalent to variable equals variable plus 1. So it's a super short way to do it. And I haven't researched why, but for whatever reason, Guido, the creator of Python, decided that was a bad thing, and we don't quite have the shortest operators that we might have in a language such as Perl or C or Java. A sentinel value is a flag or special value that marks the end of sequence items. So this would be a bad example to use 0 as a sentinel value for entering grades for a student, because students on occasion do get zeros on assignment, usually because they just did not turn it in. But maybe in that case a -1 would be an example. Your grade is presumably going to be between 0 and 100 inclusive. So if you hit a -1, that is not a value that is a valid grade. So you could use that as your sentinel value. So here they say it must be distinct enough as to not be mistaken for a regular value. So in the case of grades, -1 fits that. Another thing is if you're reading input from a file. I think we have 2 or 3 more chapters before we get to file I/O, but as soon as we do, you'll be modifying one of your programs to incorporate a loop that reads from a file. So what they're saying here is an empty line in a file could be used as a sentinel value potentially to indicate that you have no more values that you want to process. Another thing that's been a term that's been around for forever related to programming is garbage in, garbage out, which is basically if you feed in valid data into a program, the program is probably going to give you invalid or garbage results. So when you get input from the user, you should always validate the input. Now then, in your next couple of programming assignments, I'm going to give you very specific test cases and tell you, here are the test cases you are to use, and you are to use nothing else. The reason for that is if you put in sets of values, you can cause your program to get runtime errors, which means it was running but it aborts because something bad happens, like for example taking the square root of a negative number. If you've had enough math you may know that taking the square root of -1 as an imaginary number in math, by default, Python is going to only allow you to take square root of values that are 0 or greater. And if you try to take the square root of a negative number, it's going to give you a runtime error. It's just basically going to go, hey, I can't do that, and terminate execution of your program. Now, I haven't really investigated this. I know Perl has what they call a complex library for math, which will do complex and imaginary numbers. But by default, the math module or the math library in Python does not like to take square roots of negative numbers. So when you're done with a program that takes a square root of a value, you're going to hopefully check for that and warn the user before you actually attempt to take the square root of a negative number and your program blow up with a runtime error. So that's what input validation is. That's inspecting the data before you actually use it to do something. In my example, perform a calculation that we know is going to fail. So here's an example of validating your input within the decision block, and if it's good data, then actually, sorry, I was reading this wrong. So if your input is bad, you tell the user, and then you prompt them to give you the input again. So you have this validation loop that you will not get out of until the user actually gives you valid data. And then when you fall out of this decision diamond with a false answer, meaning that the input is good, then you would perform whatever processing you needed to do with that now verified good data. Here's an example using the walrus operator, where if you kind of look at what's nested, the first thing that's going to happen is that innermost input, which is enter a score. Presumably that score, I guess, can only be integers, or they want to round it to an integer. So they use the int function and they assign it to score. But at the same time, that return value is used as a while, and or is returned and then compared to 0 and used as a condition for the while. So basically what this is going to do is, while you're giving scores that are less than 0, it's going to say the score cannot be negative, and turn around and execute that input as statement again, which is going to prompt you to enter another score. Mentioned this earlier, you can nest loops within loops. You can nest any control structure type within any other type of control structure. So here you might have an outer loop that's counting hours, and then an inner loop that is counting minutes. In my example, the outer loop was processing students, the inner loop was getting grades for those students and calculating an average. So here is what a loop within a loop looks like from a flowchart simulator, where you're simulating the clock. It's going to go through and basically count time for you. The inner loop, when you have nested loops, I like to refer to it as moves faster. That is, all the iterations of the innermost loop will execute, then you will back out one layer of the loop. So the total number of iterations is going to be how many times the inner loop executes times how many times the outer loop executes. Now then, There are situations where you might want to terminate the current iteration of a loop, or possibly terminate the entire loop because of something that's going on. And the statements to do that, first there's the break statement that will totally have you jump out of the loop, and flow of control of execution will go to the line after the loop. So you'll see they set a counter variable to 0, and then there's an increment of n plus equal 1 at the bottom. So presumably you're setting up for this loop to run 100 times. Now, there might be some condition. This is kind of an example to show you how this works. This would not be a real life example, because if you really only wanted it to execute 5 times, then you would say, well, n is less than 5. But a good example, nonetheless, if n is equal to 5, it's going to break, which means it's going to jump out of the loop and then continue on with the print statement, which in this case prints the loop stopped and n is 5. So break totally gets you out of the loop. Now, if you want to, for whatever reason, stop processing the current iteration of the loop and go to the next iteration of the loop, then you use a continue statement to do that. So here's an example. This loop is going to execute for 10 times. So when we go in the loop, it increments n to 1, and then it says if n mod 3 equals 0, continue. So that case it would jump back up to the while loop and check that n is still less than 10. Otherwise we print n. So if you think about the mod operator and or look at the output, basically what it's saying is, for the range, print out all my numeric values that are not divisible by 3. That is, if I divide by 3, I get a 0 remainder. So you'll see that it goes 1, 2, 4, 5, 7, 8, 10. So 3, 6, and 9 do not appear in the output. Now then, I am not sure, but the only place I've ever really seen this is in Python, and that is putting an else statement after a loop, whether it be a for loop or a while loop. And basically what happens is the else will be executed after normal execution of the loop, or where I find it more handy is if you are not going to execute the while loop at all, that is, there are just 0 iterations, then the else clause is going to be executed. So to me it's kind of a weird construct, but nonetheless we need to be familiar with it in case we encounter it, or in case we have a problem that we could solve using that construct. They claim it's only useful when it contains a break statement. So if you have a break, it's going to jump over the else, is what they're trying to tell you. But I think it's useful in that there may be situations where if the loop never executes, that you have that else clause. So here's an example of where they go through and they use a break, and they're counting numbers and then they're breaking out of the loop, and because you terminated the loop with a break, it is going to jump to, like I said before, the next line of code after the, in this case, for loop, and that for loop does include the else clause. So it's going to basically break all the way out and never process the else statement. Here's one where, because we're doing the range 0, 1, 2, which is what you get if you do range 3, we never encounter n equals 5, therefore we never break. So what happens is once we normally terminate that loop, it prints out after the loop n is, and prints the current value of n. Okay, so that's the discussion of looping, and as is often the case, we end the chapter with some turtle graphic stuff related to the current topic. So here they're using a for loop and the range function to draw a square. So basically from the origin they move forward 100, which would be to the right. Then relatively, we would use set heading to give an absolute direction, but here the right function is saying turn 90 degrees to the right, and then it will go back and go forward 100, which is the line down on the right side. And when you do this, it will draw the 4 sides of a square. So it's something we can kind of use the Turtle Graphics command and calculate or specify movement within a loop. Here's one drawing an octagon. So it's very similar. Instead of 4 sides, there are 8 sizes. So the range gets changed from range 4 to range 8. You're still drawing each line to be 100 pixels long. But instead of turning 90 degrees, you're turning 45 degrees each time to draw one side of the octagon. Here's one that draws kind of what looks like a spirograph figure. If you're, if that's a toy you had when you were younger. I was trying to visualize how the center of the circle was moving. So what I did is I typed this code in, and before the for statement I set the speed of the turtle to 9, which makes it go pretty slow, so that I could actually see it drawing the individual circles, and from that kind of judge how the center point of the circles was moving around. Here is one where you're drawing, I don't really call it a starburst. I was going to say something that's kind of star looking. And you do that by going through and changing the angles and drawing a line up and a line back. They're taking the pen up and down and using a go-to change the start position, and then they're going through a range specifying however many lines you specified. Okay, so that finishes up chapter 4. You can read over this slide. I'm not going to read it to you. But basically, this is some of the major topics that we talked about in this chapter.